Hello, everyone. Today we will be learning about ratios. So, students will learn about the definition of a ratio and the basics and applications of its uses. Some skills that you will acquire will be identifying some ratios, comparing ratios, solving ratios, especially in word problems, and just understanding them as a whole. So what is a ratio to start off? A ratio compares the relative sizes of at least two numbers. You've probably heard of the word proportions, but ratio is a more mathematical term that you'll see more frequently if you haven't already. So there's multiple ways to represent a ratio. The most common are those four that are right there, but there are other ways to represent ratios. A colon, a fraction, a decimal, and a percent. You've probably seen these already working with fractions, working with decimals and percentages, probably a little bit. The colon could be a little bit new, but they're all key. And they basically do the same function, uh, you know, comparing the two numbers. So you see that there's one green circle over here, and there's four blue squares. Well, it equals all these three same things, and if I was going to do a percentage, it'd be, it'd be 25%, let's say. But 1 to 4 is the same as saying 1:4 or 1 fraction 4. It's all the same thing. It's comparing how many circles you will have to these squares. So for instance, let's say we had 2 circles. Well, it's saying that we would have 8 squares, and we will see how to solve for that later. But just to get comfortable, really any way you use these four, they will all be correct. And if we want to use a decimal, we could say 0.25 is the same. Just a little joke. Are monsters good at math? Not unless you count Dracula. And already you can see some of those 3 or 5, some of those fractions already. And yeah, so let's keep going. So working with ratios, you would think looking that the 3 to 1 is different than the 6 to 2, but they're actually the same. Right? So be careful with the wording is definitely key. We're saying 3 blue squares to every 1 yellow square. It's very important that we don't switch those numbers. We want to make it very clear that it's those 3 blue to 1 yellow. And the 6 to 2, let's say we had 6:2 because they're using a colon there. So I'll stick with a colon. But if we have a 6 and 2, how is that the same as 3 and 1? Well, it's the same because if you divide the 6 and the 2, if you divide the left and the right hand side, 6 divided by 2 is 3, and 2 divided by 2 is 1. So we're saying that 6:2 is the same as 3:1. And at the bottom, we have another picture saying that 4:5 is the same as 8:10, right? Because if we multiply the 4 by 2, that equals 8. And if we multiply the 5 by 2, that equals 10. So saying 8/10 is the same as 4/5. So let's just make sure we understand the proper wording as I mentioned earlier in the slide. So there's this statement. There are 7 baby lions. 3 are girls, 4 are boys. And to the left is that picture of a lion and her cubs. So the first statement is saying the ratio of boys to girls is 4 to 3, right? So there are 4 boys and 3 girls. So that 4 right there corresponds to the boys, and that 3 corresponds to the girls. Now we can say the same thing and just switch up the wording, saying girls to boys, and now we just switch the numbers. There's 3 girls and 4 boys. It's very important that for instances like this, that we make sure we correspond the first number with the first amount that we're comparing. The third statement says the ratio of boys to babies. So that is saying that there are 4 boys, but there's 7 babies in all. So the boys to babies is 4 to 7. For the girls, it's 3 to 7 because there's only 3 girls. So let's try an example. We have 15 chocolate chips, let's say, on the left, and we have 20 white chocolate on the right. Now, what's the ratio of chocolate to white chocolate? And if you're watching this video, you can pause it, try to work out the math on your own, write it down if you want, get a piece of paper and pencil. But already looking, it becomes the ratio of chocolate is 15. So we have 15 colon, right? That 2 represents that colon, and white chocolate is 20. So we have 15 colon 2. We can think of that as a fraction, right? The colon can be a fraction. Let's say it's 15 over 20. Well, we can simplify 15 over 20 as 5 is divisible by both 15 and 20. So 15 divided by 5 is 3, and 20 divided by 5 is 4. So our new ratio would become 3/4, or 3 to 4, or 75%, or 3 colon 4, however you want to represent that ratio. Right, perfect, 3 to 4. Just another problem, what's the ratio of triangles to squares? Well, first, unlike the other problems, this problem does not give us the number, so we have to count the numbers. Counting the green triangles, there are 10 of them. And counting the squares, there are 13. So because it says triangles to squares, we correspond the 10 with the triangles and the 13 to the squares. And if we want to make it even easier, just if this is your first time, we can say even 10 to 13. We don't even have to use the colon or the fraction or turn it into a percentage or turn it into a decimal. We can just say 10 to 13. I think, in my opinion, it's easier just doing 10 colon 13, but you can do whatever you like. So just another little joke. I understand that they all have the same value, but I have to tell you, the ones on the right feel like more bang for your buck. It's a little joke because they're all the same, and that's what we've been doing, really, right? Let's say the one on the right, it was 18 to 16. Well, we can just simplify that to 1 to 2. But he's making a joke just that it seems like the one on the right would give you more. So now we're going to work with scaling, reducing, and working with a table with ratios, because there's many different properties that ratios come in hand, and different forms that you can see them in. So, right, just to give you a visual representation of scaling the ratios, right, we're scaling a ratio by like a factor of 2, let's say. We have 2 to 16. If you look at the very bottom, you can see 2 green circles and 16 blue squares. To simplify that ratio and to have it be the same ratio, we can just divide the 2 and the 16 by 2, and that will give us 1 colon 8. Um, we can go the same way around. We can, if we want to make it larger, we can multiply by 2. We would multiply the 1 by 2 and multiply the 8 by 2, and that would give us 2 colon 6, 2 sixteenths. So 1/8 and 2 sixteenths are the same exact number, just 2 different ways of representing that ratio. A lot of the times you will have to simplify. Your teacher will want you to simplify the ratio, get it down into its simplest form. You'll hear teachers saying simplest form for the fraction, simplest way, just write any number that there are, just to make it more visually appealing, more just to simplify the number. So that's what scaling ratios does, is if you can understand multiplying and dividing ratios, then you're going to be all set, right? So this is an example of reducing ratios. So Pikachu to Pokeball is this example, right? And it's saying that there's 25 Pikachus and there's 10 Pokeballs. Well, if you divide the 25 and the 10 by 5, it's the same as saying 5 to 2, because what that is saying is that for every 25 Pikachu, there are 10 Pokeballs. But it's the same as saying for every 5 Pikachus, we'll find 2 Pokeballs. There's another one. Let's look at the top right. The top right has 20 colon 2, 20 over 24. Well, it's the same as saying 5, 6. It's saying how many Pikachu there are to Pokeballs. Now that right-hand number, that red number, is just the simplest form of saying it, right? It just looks better, and it's just easier to comprehend that for every 5 Pikachu, there are 6 Pokeballs. Now, it's the same as saying 20 Pikachus for every 24 Pokeballs, but it's just important to understand that you can just reduce them, and it's the same exact ratio. Now let's look at the bottom left. The 14 divided by 16 is the same as 7 divided by 8, because you're just dividing the whole thing by 2. You can think of, if you want to just do it, you can think of 14 multiplied by 1/2 or divided by 2, but whatever it is, it's the same. You can look at the bottom right again, another one very similar to the past 3, just divide it by 5 and you'll get that 5 colon 3. So why is this significant? So let's go into an example. Let's say we are baking, right? And the recipe calls for pancakes for one person, right? We love pancakes. Who doesn't like pancakes? And let's just say it's a very simple recipe. 5 cups of flour, 3 cups of milk. However, let's say you're not just baking these pancakes for yourself, but you want to bake it for your whole family, right? Let's say I have 4 people over. So what do I do? Do I just do this recipe 4 times? Well, that's basically what you are going to do, but instead of, doing the whole thing, mixing the flour with the milk and then putting it in the oven and then waiting and then doing that 4 times, you can just simplify it. And this is where the reducing and scaling comes into factor. We want to make this ratio actually bigger, and we want to make the recipe for 4 people. So what we do for 4 people, instead of dividing, right, we want to multiply. So if we multiply the 5 by 4 and the 3 by 4, we have 20 colon 12. So the ratio is 5 to 3. And if we multiply each by 4, because we have 4 people now, it becomes 20 cups of flour and 12 cups of milk. So that way you don't have to do it 4 times. You can just do one big mix and have it served for 4 people, right? So let's try a problem that you may have seen similar stuff already like this, but let's say we're working out, right? And the left-hand column represents the hours we worked out: 9 hours, 18 hours, 27 hours, and 36 hours, right? And the calories burned increase at the same rate. So because the left is what we can do, there's 2 ways, well, there's multiple ways, let me say, that we can solve this problem. If you want to use ratios, we can do ratios. Actually, let me explain the first way. You may just look at, you can see that the left hand is all proportionate, that it increases by 9 and decreases. And you can just see, you can just do the reverse, right, for the calories burned. And that's basically what we'll do for the ratio, right? For every 36, there's 50. For every 27, there's 35, 18, 20, 9 is what, right? And we can see that because the left hand is proportionate, right? It's they're all multiples of 9. We increase by 9. And for calories burned, let's say we start 50, we can see from 50 to 35 is a decrease of 15. From 35 to 20 is a decrease of 15. So we can see that we subtract 15. So what we can just do then is subtract 20 from 15, and that'd be 5. So at 9 hours working out, we will burn 5 calories. That's obviously not true. You'll obviously burn more than 5 calories working out for 9 hours. But just as an example, for this problem, the answer is 5. So now let's move on to rank, percent, and balance. So let's start with ranking them biggest to smallest. Now, right, these are the fraction form of these ratios, right? And we want to compare them. Well, the easiest, there's many ways we can just solve this problem. Looking at this problem, you can do many things. You can turn the bottom all, you can turn the bottom number all to the same reciprocal uh, denominator. So you can make that um, one would be 140. No, 120, my bad. So an easier way just to look at this is looking at the ratios and sort of just comparing one to another and another to that one, and sort of just move it. So 1 to 3, let's say 7 to 8 and 1 to 3, right? Well, just looking at that, right? Let's say I make the 1 to 3, right? 1 over 3 is the same as 1 to 3, right? Is the same as multiplying the top and bottom by 3, which is 3 to 9. Well, we have a 7 to 8 and then a 3 to 9. Obviously, the 7 to 8 is bigger than the 3 to 9. So we can say the 7/8 is bigger than the 1/3. And then we need to compare the 1/3. Then we need to compare the 2/5 to the 1/3 and 7/8. Well, 2/5 we can say is also the same as 3 to 15. Oh no, excuse me. We can say 6 to 15. And for 1/3, it's 3 to 15. So 2/5 is bigger than 1/3. Now, is 2/5 bigger or smaller than 7/8? Because right now the order is 7/8, 2/5, 1/3, or it's 2/5, 7/8, 1/3. And just to solve that, we could make the bottom 40, and just see the top number. We could do a little estimation. 7/8 is pretty close to 1, and 2/5 is pretty close to 1/2. So that would just be proper justification to say that 7/5, 2/5, 1/3. And if we want to use ratios, we can do it. We can say that for 7/8 it's 35 to 40, and for 2/5 it's 16 to 40. Either way, you come up with the same conclusion that the order would be 7/8, 2/5, 1/3. Right? And that's the answer. Let's try another one, right? This is now more numbers. 2/3, 4/5, 1/2, 1/4, 5/6. Okay, so initially I'm looking at this problem and I can tell right away that my bigger numbers are going to be 2/3, 4/5, and 5/6, and my smaller numbers are going to be 1/2 and 1/4. So how about let's just compare 1/2 and 1/4, right? Because those other three fractions are all bigger. Well, 1 to 2 is the same as 2 to 4, and 2 to 4 is bigger than 1 to 4. So 1/2 is greater than 1/4. So we have those two arranged. Now we have to arrange those other three to combine it with those two. Well, the 4/5, many of you may know, is 0.88 over 10, right? That's very common. And we can make the 2/3 and 4/5 and 5/6 all the same bottom to then compare the top, right? You've probably used this with fractions, right? A fraction is a ratio. So let's do that here. Let's say the bottom is 30, right? 20 over 30 would be 2/3. For 4/5, it would be 24 over 30. And for 5/6, it would be 25 over 30. So what that is telling me right now is that 4/5 is bigger than 2/3, right? And then to then compare that to the 5/6, well, remember the 5/6 was 25 to 30, and the 4/5 was 24 to 30. So the order is actually 5/6, 4/5, 2/3, 1/2, 1/4. And that is the correct answer. So let's move on, right? And the rank now is equal. And what I'm asking you, if you want to pause the video and do this on your own, are those two numbers equal? So pause it if you want to try on your own. I'm gonna keep going and explain each one. So why is the first one no? Well, the first one's no because, right, let's say we use these as ratios, 3 to 4 and 9 to 16. Well, 3 to 4 is the same as saying 12 to 16, and 12 does not equal the 9, right? We want to make we're asking is basically the top number the same when the two bottom numbers become the same. And the answer is no there. What about 4/5 and 20 to 25? Well, if we multiply each by 5, right? Or we can divide the 20 by 20 and 25, right? Let's do that. 20 divided by 5 is 4. 25 divided by 5 is 5. So 4/5 do equal 4/5. Now we have another one, 2 to 4 and 6 to 16. Now, what we've been doing a lot is making the bottom number equal and then comparing those two top numbers. But what we can actually do for this one, right, we can just divide each by 2, and that'll give us maybe a little more clarity, right? 2/4, many of you probably know, is 1/2. And 6 to 16 is the same as 3 to 8, right? And 3 to 8 is not equal to 1/2, so that's why it's no. Now, 1/2 is clearly not 5/6. We don't even have to look at we don't have to even compare the ratio is bottoms, we can just see that 1/2 is 0.5 and 5/6 is approximately close to 1. Not exactly 1, but it's very close to 1. So we can just really say no, right? I'm not asking you to explain it. You can just mentally think that 1/2 is nowhere near 5/6, right? And the last one's a little tricky. You might think at first it's the same, but when we look at 3/12, that's actually 1/4. So 1/4 is not equal to 1/3. So now we're going to move on to balance the equation. Now, let's say we have 8 slices of pizza in 2 boxes, right? We have a, a whole pie, right? And we put it in 2 boxes. We want to know how many pizza slices there will be per box, right? So you can visually see. Let's look at this pizza, right? We have 8 slices here, and we want to put it, and that goes in 2 boxes. So we want to know how many pizzas are per box. Well, we can easily just separate this in half and see how many boxes, how many slices of pizza will be in per box, right? And what we're doing is basically dividing the 8 and dividing the 2, because it's 8 to 2, and we're making it 4 to 1. And that 1 represents per box, right? The number of boxes, that's the second number, and it's the second wording in this phrase. And the 4 corresponds to the number of pizza slices. So the answer to this one is 4. Balance the equation again, right? We have 4 pigs and 4 pens. How many pigs per pen, right? Let's say a farmer wants to know how many pigs he can put in 1 pen. Equally distributing the pigs so there's no overcrowding, there's no undercrowding. And what you do here is, right, we want to get the ratio 44 to 4 to be the same as blank to 1, because that 1 is per pen, right? That phrase is basically saying 44 pigs in 4 pens equals blank pigs in 1 pen, right? Per pen, 1 pen. And to do that, to get 4, dividing 4 by some number to 1 is just dividing that 4 by divided by itself. So we're dividing 4 by 4. That means we have to divide the other number by 4. So it's 44 divided by 4, which is 11. So 11 pigs per pen. Let's try percentage one, right? That was another form of a ratio. Now, I will admit that percentages they look a little more intimidating. They're a little more complex, and they are. You'll see percentages, in businesses, doing taxes, things like that. But let's just look at this context of problem, right? What is 30% of 60 Sour Patch Kids? Now, a trick I like to do, and I still do it, is 30% is a very easy percent. It's the same as saying 0.3, right, of some number, right? And what we want to do, right, is what I like to do is look at that number 60, right? And what would be 10%? Well, 10% of 60 is, we can just move the decimal over 1 to the left, right? Because that number, it's 60 decimal point could be there after the 0. So if we move that decimal point in front of the 0, our number becomes 6. So 10% of 60 is 6. Now, to get it to 30%, we can just multiply that 6 by 3. So 18 Sour Patch Kids would be 30% of 60. So let's try another one. We have 40% of 20 Swedish Fish, right? We love candy. Who doesn't like candy? And we'll do the same trick. We'll do 10% first. What is 10% of 20 Swedish Fish? Well, we move the decimal point over, and it becomes 2. So 10% of 20 is 2, but we want it to be 40%. So let's multiply the 2 by 4, and it becomes 8 Swedish fish. And if you click at the bottom of this slide where it says interactive multiple choice, it will take you to a site where you can practice these percentages of food. And it's an interactive, just fun game to play. I highly suggest just looking at the links. There'll be multiple links through the slides. But yeah, just to try it out, just to enhance your learning a little bit more, because percentages are probably one of the trickiest ratios to learn. Percentages and decimals are probably the two hardest. So definitely you could practice that a little bit more just to further your learning. So, right, let's try ratio of a shaded region to the circle. Hint, and there's a hint at the bottom, both circles show the same ratio. Now, the right one looks a little more intimidating, right? There's a lot more slices. So we can start with the left one and then work our way to the right one. And hint, both circles show the same ratio. So that means it doesn't matter what circle we use. So we can count the number of slices in the left one, and we can see that there's 7 slices in all. And there's only one shaded. So shaded corresponds to the 1, and circle corresponds to the 7. So what we're saying is 1 to 7, or 1:7, or 1/7, or we can turn 1/7 into percentage, or we can turn it into a decimal. It's the same thing, 1 to 7, right? That's the answer. I would like to also look though at the second circle, the one on the right. Right, it looks very intimidating, right? Because if we count all these slices, there's actually 21 slices. It looks like a lot of slices, right? And we see 3 shaded slices. Well, that's the same as saying 3 to 21. And if we divide each by 3, it becomes 1 to 7. So you get the same answer, right? The hint even told you that. You get the same answer by doing either one. Even though one looks like it has more slices. Even though it has more slices, the shaded region then becomes sliced. So it's not that the shaded region becomes bigger somehow, right? And that was that joke early on. It looks like you're getting more bang for your buck. You're actually not, right? And that's why I had put that joke in there. Getting 3 slices is the equivalent of getting 1. You know, you might think, oh, I'm getting 3 slices, and it must be so much bigger. But it's not if that 1 slice is just as big as those 3 slices. So be very careful when you want to compare these sizes. So let's go on to some word problems using ratios. Right? This is one we can do together. Right? The Cookie Monster. There are 84 cookies for 28 students. Now, we want to know how many cookies are needed for 30 students. Now, this is very complex. And that's why I put in the answer. And the reason why it's complex is the denominator. What we're doing is we put the 84 cookies, right? The C stands for cookies, and the 28 students, right? That's the ratio. 28 to 20. I mean 24. Excuse me, 24 to 28. And what we do is we need to set the students to 1 student. Right? And that's what they're doing. They're doing 84 cookies over 28 students needs to equal blank cookies over 30 students, right? We only have 1 variable. And there's many ways to go about it. You see, like, they divide by 4, then they divide by 7. And right, that's basically what we're doing. But I'll give you a hint. 28 goes into 84 3 times. And by giving you that hint, That means, right, it's basically dividing by 4, then dividing by 7. I just want to simplify it for you, that 3 cookies will be for 1 student. And now knowing that, that ratio becomes so simple because we can multiply the students now by 30 and multiply the top by 30 and get 90 cookies, right? So it is 84 cookies to 28 students is the same as 3 cookies to 1 student, which is the same as 90 cookies to 3 students, right? It does look a little more complicated at first, right? How do we get those bottom numbers to be the same? How can we get that answer of the number of students, right? Because, it's 2 students off, you know, by knowing that, right? And even if you get to the 3 cookies to 1 student and you're not sure how to get to the 90 cookies for 30 students, what you can do is 1 cookie is for every, well, I mean, excuse me, 1 student is for every 3 cookies. So we can just add 2 students, add 6 cookies because we're adding twice the amount then, and that becomes 90. So either way, you will get 90 cookies. That is very complex. Don't worry if you don't get that straight away. What they had done here is divided 84 and 28 by 4 to start. Just a very simple division to get 21 over 27. And then they saw that 7 goes into, again, right? 3 would be on the top and 1 is on the bottom. And just there's another link here for extra ratio practice. Some of these more complex problems, I highly suggest you go take a look. It's important that you understand this topic, especially in word problems, because you will start doing this in your everyday life. I showed the recipe problem, cookies like this. Let's say, right, you bring cookies to your class, but you want to distribute each cookie properly, like that would be it, right? Let's say, you saw something like this, with the cookies, um, and you realize there were 28 students in the class, and you actually counted wrong, and there are 30 students, and you want to know how many more cookies to make. You can see that ratio, 3 cookies per 1 student, then you can just multiply that by 2 and then get an extra 6 cookies, right? These ratios are, you use them in everyday life. So let's try another ratio word problem. Alexander counts cars and trucks on a road trip. He counts 9 trucks and 13 cars. What's the ratio of the number of cars to truck? This is a very simple problem, right? We have the number of trucks, we have the number of cars. So it's very important that we understand, is it 9 to 13 or 13 to 9, right? The wording is so important in this. I can't stress that enough, right? The first part is cars, right? So it's not the 9 trucks, it's the 13 cars. So it's 13 to 9. Now, if you put 9 to 13, that is wrong, okay? And let me try to explain it a little more simplified, right? Like, we're saying that there will be more cars than trucks with that 13 to 9, because let's say it's 13 over 9, right? That's 1 over 4 nines, right? We have a whole already. So there can't be more trucks than cars. And we know that because it says 9 trucks and 13 cars, and the trucks is obviously smaller than the cars. So let's try another one, right? For every 46 pages of an essay Christopher writes, he watches 32 videos, right? He's very distracted. He's a procrastinator, has trouble writing these essays. So we want to know, what's the ratio of videos to pages? I forgot that too, my bad. Right. And we know that he watches 32 videos. And we know that it's for every 46. So 32 to every 46. But I can tell you right now that just looking at that, because both numbers are even numbers, a little trick right there, that if both numbers are even numbers, 2 is divisible by both of them. So we can just divide each by 2, and 32 divided by 2 is 16, and 46 divided by 2 is 23. So right now we have 16 to 23, and that looks like it will be the smallest form. So the answer right here is 32 to 46, okay? It's the same as saying 16 to 23. So kudos if you said 16 to 23. You already simplified it. I didn't simplify it here, but if you did, you're already ahead of the game. So let's try now. Jack's unicorn gained 48 pounds over an 8-week period. Right, and let's just say that obviously unicorns are imaginary, but let's say we had like a horse or a dog, right, your pet, a fish, a cat, whatever, and you saw it grow over this period of time, and you want to know how in how many years, how much it would grow if it kept growing at the same rate. Well, this is where it comes in. You can see how big your pet will be, or you can see how big it was when it was a puppy, and now how it compares to a dog. Right, and we can keep going this word problem, right? If the unicorn keeps growing at the same rate, right, it's important that it doesn't grow at an exponential rate or starts decreasing or whatever. It keeps growing at the same rate. We want to know how much weight will the unicorn gain over a 4-week period. And this problem is actually very simple when you look at it, because gain that 8-week period to 4 is just you divide, right? We want to know 8 multiplied by something would give us 4. Or that we can say, that's just one way of saying it, right? Because then we can divide the 8 on both sides and see that, that x value would equal 4 over 8, which is just 1/2. So we want to know then what's 1/2 of 48. And 1/2 of 48 is just 24. So, right, how much weight would the unicorn gain over a 4-week period? Is 24 pounds. And right, you may be wondering, how is this a ratio problem? That'd be a great question, right? What we're saying is, right, if we just pull out these numbers, is what I'm gonna do right now. We're saying 48 to 8 equals blank to 4. Right, that becomes a very simple ratio problem, right? If you can visually just imagine that balance equation. That's why I showed you that's why we had done those balance equations before, because that's a lot what ratios are, is balancing the equation, right? We have that equal sign. You may have done this with fractions, right? We can see that 48 over 8 equals blank over 4, and we can multiply each side by 4 and then just get an x value, right? It's all the same concept. It's all the same mathematics. It's just different ways of approaching it. And I hope you have enjoyed this video. Just a little bit about myself. My name's Aiden Silverman. I live in Baltimore, Maryland. I'm a junior at Boys Latin, and some things that I just love to do. I love playing sports, soccer and lacrosse. I love going outside, and that's actually a picture of me at camp last summer. So I really do hope you have enjoyed this video. If you have any questions, concerns, if you have trouble accessing any links, or you want even more practice, please contact me. I'd be more than happy to help. This next slide also has some of the sites that I did use for this presentation. So if you just want to take a look at any of the slides, information, a lot of it I come up with from previous math knowledge, but just in case you want to maybe look at some of these sites, maybe they can take you to other sites for extra practice, or if you still were a little confused on section. So thank you.